When we're looking at linear systems, what we're looking at is a set of at least two or more lines that's considered to be together. So it's like a group of two or more lines that are together. Now, a point of intersection is actually the solution of those lines. So it's where two or more lines cross. Now, when we're talking about a solution, what we're actually looking at is the point of intersection. It's a spot where both or all the lines can exist. So if I put the point into either line, it's going to make the equation true. So if we're looking at a linear system, the way we're going to solve these linear systems in grade 9 is by graphing. Now, there's a bunch of different ways that you can actually solve a linear system, but for what we're going to do is we're going to put everything into y equals mx plus b, and then we're going to graph it. So it says solve each system. So what that means is we need to find the point of intersection. So for our final answer, we need to have a point of intersection. The first graph is already in y equals mx plus b. So we've got m equals 1 over 2 and b equals negative 3. Now the second graph, we need to rearrange it to this. We need to move the x over. I'm going to change colors here. We'll have the second graph be red. And the slope of the second graph is m equals negative 1 and b equals negative 6. Excuse me. So now just because I have the red out, I'm going to start at negative 6. I'm going to go down 1 and over 1, down 1, over 1. So this is what my graph for that second line looks like. So we're going to look something like this. I'm trying to do it as straight as I can. All right. For the first graph, we're at negative 3. And we're going up 1 over 2, up 1 over 2, up 1 over 2. What we need to notice is that we're actually going to intersect. So our graph's going to look something, whoops, that's a bad line. Let's try that again. Going to look something like that. Now here is our point of intersection. So we just need to state it. Therefore, POI is negative 2 and negative 4. Okay, so that's what it means by it exists or it satisfies both equations. It means that the point of intersection is actually on both of the equations. Okay, it's on both of the lines. So our POI here is negative 2 and negative 4. All right, let's look at another example. So here we've got a slope of 1 and a b value of 2. Now, if you've done your homework from the last unit, you'll notice on this next one, we've got a slope of 1. We actually have plus 0 here. So we have a b value of 0. So again, I'll do the blue one first. Slope 1, b value 0. So we're going to start there. We're going to do this. We're going to do this. And our graph's going to look something like that. Now we'll get the other graph going, which is starting at 2. We've got there. Let's see how good I've drawn this. And what you should notice, because they have the same slope and a different y-intercept, these graphs are parallel. They're never going to touch. So therefore, there's no solutions for this graph. Okay, this graph is never going to intersect, so we're never going to have a solution for this system of equations. Finally, this one. This one's a little bit harder. So what we need to do here first is we need to rearrange the equation. So we'll get 3y equals negative 2x plus 6. Then we get y is negative 2 over 3x plus 2. Now we know our slope is negative 2 over 3, and our b value is 2. Next, we'll look at the second one. We've got 6y equals negative 4x plus 12. Then we get y equals -4/6x plus 2. So we get a slope of -4/6 and a b value of 2. So what you can see is I actually have already graphed this. So the point of 4, or the slope of -4/6 can actually change to -2/3. And what we notice is that both of these graphs are identical. One graph's on top of each other. We've just written the equations different at the start. This equation is the same thing as this equation. They just look different at the start. So with this system, we have actually infinite solutions. Any point that we choose that's on the line is going to be a solution. So as long as the point's on one line, it'll be on the other one. So when we're looking at these, we can have either, so you can either have one solution. So let's actually do this. One solution. And with that, we have different slope we can have infinite solutions, and that's where the lines have the same slope and the same y-intercept. And finally, we could have no solutions. And that would be the same slope, but different y-intercepts. Let's look at one more example. So we've got a word problem here. So a couple has budgeted $5,000 for their wedding reception. Which hotel offers the better deal and under which conditions? So the first one is the Waverly Inn. So let's make the Waverly Inn blue. And we're going to say, we're writing an equation. That's what A says. So we've got the Waverly Inn. We're going to say it's C equals, well, it's $250 fixed and then $50 per guest. So we're going to say 50N plus 250. Now, Hotel Niagara, we'll do over here, has a $1,500 fixed, but then it's only $25 per guest. So it's going to be 25N plus 1,500. Now, what we need to look at here is which graph or which situation is going to be better, but not only that, and when. Okay? So we've got $5,000 total. That doesn't mean that they're necessarily going to use $5,000. Okay? So let's look at the equation. I've got the red marker out right now, so we're going to go 1,500. And then I'm going up by 250. And if we look at our scale is counting by 250. So I'm going up by 250 each time. So what we're going to do is if I look at this, every 10 customers, I go up by 250. So my graph, sorry, I'm going to erase those other dots that I put on there. So my graph is going to look like this. Every 10 customers, I'm going up by 250. Now, if you have a ruler, you don't always have to put all of the dots. I'm putting them all just so that I can connect them all nice and clean, make the graph look nice. So there's the Hotel Niagara. Now the Waverly Inn starts at 250. It starts way down here, but it's going up 10 times 50 is $500 each time. So every 10, it's going up 500. So it's going up like this. So it's going to look something like that. And then our graph looks something like that. So right there, this point is an important point. That's our point of intersection. Okay, that happens at 50 and 2750. Okay, so that's our point of intersection. Is the Waverly Inn or the Niagara Inn a better deal, and under what conditions? So what that means is that the blue line is a better deal all the way up until we get to the point of intersection. However, after the point of intersection, the red line has now become the better deal. Okay, because we always want to pay less. We want to be under the cost. We want it to be the lowest it can be. So what we have to say then is kind of three things. So I'm going to write my therefore statement just here, just so we've got a little more space. So we've got therefore, if there are less than 50 guests, what is it? It's the blue line. Waverly, how do I spell this? Waverly is better. More than 50? Let's get rid of that arrow. More than 50? Hotel Niagara is better. And if exactly 50, it doesn't matter. So when you're looking at that, you have to state all three of those things. More than 50, less than 50, exactly 50. Okay, and here's some questions to go